Hello everybody again and welcome back. You notice we have busy boards here in the beginning. We're doing section 3.6, zeros of polynomial functions. It's very theoretical. It's very theoretical. In fact, the whole section is 5 theorems and 1 rule, which we're going to talk about in this video. The 5 theorems are the remainder theorem, the factor theorem, the rational zero theorem. And then we go to the complex plane and we get the fundamental theorem of algebra, one of the most important theorems there are, the complex conjugate theorem, and then this is a rule, Descartes' rule of sign. So that's what this this particular section is all about. And to start, we'll start with the remainder theorem, and I wrote this down because of, I didn't want to use, let's go. The remainder theorem says if a function is divided by a number, it's k, we'll call it k, then the remainder it is f at k. So what the heck does that mean? Well, here's an example, which by the way is on page 267. And again, I wrote this down beforehand because I didn't want to. So it determined f at 2 for this function. Well, you folks right now are wise enough to realize, well, all I have to do is put a 2 in there. You know, 2 to the 4th, 2 to the 3rd, etc., and multiply. But we have a tool called synthetic division, meaning we're going to divide like this. Write down just the coefficients. 6 minus 1 minus 15, 2 minus 7. And then bring down, multiply, add. That's what last section was about. Bring down, multiply, add. Bring down. Multiply, 2 times 6 is 12. Add, that's 11. Multiply, 22. Add, 22 minus 15, 7. 2 times 7 is 14. Plus 2 is 16. 2 times 16 is 32. Minus 7, plus negative 7 is 25. Boom. Guess what? F at 2 is 25. Meaning there's a point on the graph. If we graphed, we would put a point at 2, 25. And that's called the remainder theorem. Now what's going to happen is a factor theorem, and it's going to say, what, you know, suppose it's 0. Suppose the remainder is 0. Well then, it's a factor. Whoops, I'm erasing this board. Factor theorem. If f of x is divided by x minus k, and the remainder is 0, then x minus k is a factor. Factor of f of x. Which is nice because that, you know, you have a factor, then you break it down. For example, this is 1 minus 6 minus 130. Show negative 2 is a factor of, what I say, x cubed minus x minus 6x. Let me check that a second. 1 minus 6 minus 130. There we go. 1, oh, I'm so sorry. Doesn't matter. Yes, it does. Damn it, I did it again. This is why I started the tape in the first place. X cubed minus 6x squared minus x plus 30. And I want to show negative 2, I want to show x plus 2 is a factor of this. So I'm dividing synthetically, and I'm using negative 2. And so it's just 1 minus 6 minus 1 and 30. And here we go, synthetically. Bring down, multiply, negative 2, add, negative 8, multiply, 16, minus 1 is 15, multiply, negative 30, zippo. I just showed it. You're finished. By the way, I'm going to erase some of this stuff up here. By the way, what this means is x plus 2 is a factor, and then also the synthetic division. This is a 0, a 0, a 0. They add to 0, so forget that. The remainder is 0, so x So x plus 2 is a factor. X squared minus 8x plus 15. And, you know, what we're looking for the zeros, so I'm just going to factor. There we go. There's the three factors. That's what f at x is originally right there. The zeros, that's why we use the factor theorem. How about the rational zero theorem? What this says is you have a polynomial. Oh boy, this is going to be theoretical, I think. F at x is a polynomial, a and x to the n. You know, that's how we were writing it. Plus, then this is a n minus 1, x to the n minus 1, plus, and this is a sub 0. A to the first, x to the first, you know, a squared would be there, plus a to the 0. The rational zero theorem says that the only possible roots, rational roots of this polynomial are all the factors of a sub 0. And it's harder to write than it is to talk about. Divided by all factors of a sub n. So, you know, what the heck? What does that mean? This is just a way to list possible factors. So, you know, we're doing synthetic division. Well, you need to come up with something to start with. Well, this is a way to start with it. For example, rational root there. What the heck? 2 minus 5x minus 4. Minus 5x squared minus x plus 4. That's f at x. And all we're saying is list the possibilities for rational roots. List all the possible rational roots. And it's like factors of 4 divided by factors of 2. Well, what we're talking about is 4, 2, 1 over 2, or 4, 2, 1 over 1. So that's it. Those are the only possibilities. By the way, you have 2 of them twice. Here's 4 over 2, and you have 2 over 1. Here's 2 over 2, and you have 1 over 1. So it's only 2, 1, a half, or 4. There's only 4 possibilities, but there's 8 possibilities. Plus and minus each one of them. So if you're really trying to break down one of these, those are the only places you would go to use synthetic division, because it wouldn't make any sense to go anywhere else. Find the theorem of algebra. We're now going to the complex plane. Won't do anything with this, but yeah, there's not much more coming except theory. All this says is a polynomial of degree n. All it says has n roots in the complex plane. That means it's fundamental. It's a fundamental theorem of algebra. But essentially, we can write any polynomial like this. Well, you need a lead, whatever that is. But then these are all roots, and it will go on forever. These C's are different. C1, C2, C3, or whatever. They're complex numbers, and so you can write any polynomial in factored form if you include complex numbers. That's the fundamental theorem of algebra. It'll come back into play for you next year, first semester. Okay, and then we go to complex conjugate. Theorem. Oh man, my chalk's running low. I try to chalk all over the place. And this says if a plus bi is a root of a polynomial, then so is a minus bi. If you have one root, you have another root. We could do a lot of stuff with this, but let's just finish the theoretical stuff. Oh, why do I have that there? Oh no, one more thing. It's called Descartes' rule of sign. And I'm not going to get into the details of it. There we go. But if you have a polynomial, what Descartes does is analyze if it changes sign from one to another. And it gives you a possible number of roots, of real roots. And then you put a negative one in here, and it'll give you another possible number of odd roots. Actually, even roots and odd roots. I'm going to do another example video, and we'll work with this. But what I'm saying here is, this has been probably the most theoretical section that we've had thus far, particularly the end of it. You know, once we hit the fundamental theorem, you know, I didn't do any examples. I just talked about theoretical stuff. We're going to keep this simple in terms of your quiz and your homework. And I'm coming back with an example video just for the last two sections. We'll put all this together and finish root zeros of polynomial. Hey, see you next time.